Okay, triaxial shear strength. We talked about the importance of triaxial shear strength in civil engineering designs. Monday, we are continuing with this. We test a sample under 3 directional stress conditions to simulate the behavior at project sites when we apply these loads. I showed you the Word file equations from chapter 10, total shear strength in terms of C and phi and the normal stress, and the effective shear strength in terms of C prime and phi prime in terms of the effective stress sigma minus u sigma prime. To make use of these, to apply these equations, we need these shear strength parameters, total shear strength parameters C and phi, effective shear strength parameters C prime and phi prime. And the failure plane makes an angle of theta, which is 45 degree plus half phi prime. This is what we can see from the Mohr circles. And here, this is what you see as theta, 45 degree plus half phi prime, the slope of the failure plane with respect to the minor principal stress sigma 3. Also we have sigma 2 perpendicular to the plane of the board, both being equal, and sigma 1 is more, so creating shear stresses on this inclined plane causing the shear failure. The Mohr circle, sigma 3, sigma 1, sigma 3, sigma 1, 2 Mohr circles. We have a common tangent with the slope phi prime. We can also have a y-axis intercept, but in this case the y-axis intercept is 0. C or C prime is 0. This is for the first type of triaxial shear test, consolidated drained shear test. That's why sigma 3 and sigma prime are equal. So we get one set of Mohr circles, not 2 sets of Mohr circles. That's also explained in this figure. When we do this consolidated drain test, in the consolidation stage, we apply sigma 3 also equals sigma 1. That's why instead of writing sigma 1, sigma 3 is written here. We allow the soil sample to consolidate. That means we allow drainage in both the vertical directions, top and bottom, not allowing the pore water pressure to develop. We apply this deviator stress to increase the vertical stress from sigma 3 to sigma 1. Sigma 1 is sum of these two things, and we apply this so slowly that we do not allow the pore water pressure to increase from 0. Because pore water pressure is 0, we get sigma 1 equals sigma 1 prime, sigma 3 equals sigma 3 prime. There are 3 types of triaxial shear tests which are listed here in the Word file. Consolidated drain test, known as CD test or slow test. This is relevant to certain types of situations at projects. And we have consolidated undrained test, CU test. This applies to most of the cases we deal with in civil engineering. Unconsolidated undrained triaxial shear test, UU test, also known as quick test, applies to certain challenging situations in civil engineering. So let us talk about the 3 types of triaxial shear tests. 3 types of triaxial shear tests. Number 1 is consolidated drained TST, triaxial shear test, let us say TST, known as CD test, also known as a slow test. This is when the loads are all gradual, no sudden loading, and soils are well draining. That means sandy, gravelly soils. The second type of triaxial shear test is when consolidated, undrained, TST, also known as CU test. I'll write it as CU test. This is when we have some loads sudden, that means failure load is sudden. I wrote some loads means dead loads are gradual. Most probably most of the load is dead load, but failure is expected because some of the live load, wind load, or earthquake load can come suddenly, causing the failure. When it happens, though soil is well draining, will not have time to drain. This test gives both total shear strength parameters C and Phi. It gives both C and Phi, as well as the effective strength parameters, shear strength parameters, C prime and Phi prime. In this test, we measure the pore water pressure and use the pore water pressure to calculate the effective stresses, and then plot the Mohr circles or use equation 10(9) to get these two sets of parameters. That means first we subtract from sigma 1 u to get sigma 1 prime, sigma 3 minus u is sigma 3 prime. From these two things we need to draw either Mohr circles or use equation 10(9) to get these two sets of soil properties for use in design and construction. I will follow it up in the next video.